Hi, welcome to the Shiko Math Lab. And in this video, we're going to talk about how to find the volume of a triangle pyramid. Okay, let's go ahead and start. So this is our triangle pyramid. So we have a pyramid with the height is h, and the base is an equilateral triangle with the side is A. And now let's try to find, what is the volumes for this pyramid. As we know, this one's here, we can slice, right? So if we want, we can slice here. Right, so when you slice, then this is still is a triangles, right? So in order to find the area of this slicing triangles here, what we need to do, we need to have a base, we need to have a height, right? So now let's take a look. How do we? So this is kind of like we know this the concept is pretty easy. We have this triangle, but how do I find the height and the base for these triangles here? Okay, first, okay, let's say the height is h. So what is the pyramid's height? Is from this point, right? Then they dropped what? So perpendicular to, that is perpendicular to these planes, right? So this is the height. Okay, so for this height here, so the one way I can do is I can put my y-axis here. All right, so I can put my y-axis here. So then where is my x-axis here? I can go like this way. I can, when they touch in the middle of this triangle, I can put an x-axis like this. Well, of course, this doesn't look like it's okay. So I can put like the x-axis. So if this is y-axis here, right? So it's a perpendicular, it's the height. Then I can put the x-axis passing through one of the corner points here. Okay, so this will be your x-axis, is y-axis. And so let me redo the drawing. Maybe that will help to visualize what we are looking for here. All right, so let's take a look. I want to see through this, right? So here, this is my, so the view I'm drawing here is if you see this pyramid from one of this surface here, and one of this triangle, you see that. Okay, so this triangle, see here, right? You go through this side, right? The triangle, you see the inside. Okay, so let's take a look here. What is the? I hope that I can do good pictures here. All right. All right. So when you see through that, so you will see. Okay, so this is like the bottom triangle. I use the dot line. It's kind of like the bottom triangles, right? So you can see it's 3 dimension. So now I'm slicing, right? So when I slicing here, I have so this one here is my slicing. So if I slicing, I have here. All right. So this dotted line is where I kind of see in the 3 dimension. And now I know my height. Okay, so height is go from here to here, right? So height is the one from the top of the pyramid and go to, it's not a go to here. So it's a go to the, like we say, the height is dropping down to where? Dropping down in the middle of this planes here. All right. Okay, so now you still see a 3 dimension, right? And then we say where I want to put my x-axis here. So basically, so I'm connecting from here instead of I go to here. I kind of find this one, and so connecting. So you can connect to here also, or if you want to use this as your x-axis, then you just right? So you do like this, right? So the same way, right? So the same way, you know, when you cross sections here, then where is your axis connecting to? Your axis is connecting to here, right? So this is the one. So if you kind of visualize that, so it's kind of like the two triangles here, right? So this is the height to the center. So this is the 3 dimensions here. Okay, so now let's try to mark it. So this is the A, right? So then this distance, so imagine, all right, your base is equilateral triangles, right? So its base is equilateral triangle. You have a height, right? So the height, the line of the height dropping here. And what is this green line? This green line is the one you connect that height to, you know, whatever that height drop into your bottom triangles here. All right. So I will call this one. I don't know what is the length here. I will call this is B. Okay. Right. So this, so kind of imagine, right? So let me see here. Kind of imagine the bottom. All right, so the bottom triangle is this triangle. So this is a 3-dimensional, all right? So the way we view this 3-dimension is from the front of the face of this triangle, right? So you can see that. Okay, now when you cross sections, right? So you cross section, where is my cross sections triangles here? This is my cross section triangles here, this one, this blue one. Right? Okay, so now, okay, so here I start to put the numbers here. So this distance, I don't know. I called this is alpha. Okay, this distance is alpha. And from the center, remember this is where the height passing through, right? So then this centers here. So this distance here, I can call the beta. I just try to kind of the reference here. So, okay. So now the height, this red one is H. It's correct. It's right from the top all the way drop to the bottom, right? To the bottom one here. So this height is H. Okay, so if this height is H, and then what, you know, from here, okay, so now let's take a look here from different colors here, all right? Then from here to here, this distance here, right? So because I put the y-axis is here, so this distance really is what? This is what is my y, right? So this is from this plane to this plane. This is my y here. Okay, so this is my y. Okay, now I'm comparing here, right? So let's see. Let me try to first write down our first relations here. So I comparing the similar triangles here. So I have alpha over beta is equal to A over B, right? So I'm compared to these triangles and the one that touch the bottoms here, right? So this is my A, right? This is my A, and this is my what? This is my alpha. And this line connect the corner to the height drop is similar like this one, this green line connect to here, right? So I call this, see here, this green lines here, I call this green line, let me get a little bit darker, right? So this green line I call this beta. Okay, so the alpha over beta, right? So now I can solve my alpha will be what? Alpha will be beta times A over B, okay? And also now I can find the similar, you know, the triangles here. The B is here, right? So B to the H, right? So this line to the H, I'm looking for the yellow triangle. The yellow triangle, the B is this line connect to the center. versus the h, right? So these triangles here will be equal to what? Will be to beta, right? So will be equal to beta, and this is the whole height. So for this blue, so for this blue one, what is the height for this blue ones here? Is here, right? So what is this ones here? It's h minus what? It's h minus y. So that's why the b over h. So we are looking for this big triangle, right? So in a small triangle. So it's b over h is equal to the beta over what? Beta over h minus y, correct? Okay, beta equal to the h plus 1. Then I can find the beta. So the beta will just be BH, the h minus y times BH here. Okay, so now for these two equations here, so I can substitute the beta back to this equation. So what I have here, so I will have alpha equal to, what is here? Alpha equal to h minus y b over h times a over what? A over b here, right? Okay, so far so good. So b and the b I can cancel. And then here, if I factor h out, so this is 1 minus 1 over h and the times a over h, right? So now the h can cancel. So I can get this ones here. It's a times what? Y minus yh is here. Okay. Okay. So after this one's here, so now I can try to find the equilateral triangles here, right? I have alpha, I have beta, right? Okay, so now my area, okay, so my area will be, okay, so if you have an equilateral triangle, if this is the alpha, right? Then what is the height of this triangle? Because this is alpha, so the height will be the square root of the 3 over 2 to the alpha, right? That's the special triangle. So this blue cross sections here we have is 1/2 the base. The base is alpha times the height. Height is the square root of the 3 over 2 alpha here. Okay, so now we have, so what do we have here? So we will have the alpha, so it's 4. Okay, so it's a square root of the 3 over 4 for the alpha square. And what do we just calculate alpha square? And alpha square, you say, oh, wow. So alpha, we just calculate, we find that alpha is equal to the a minus 1, a times 1 minus yh squared. Okay, so here, this one will be equal to, okay, square root of the 3 over 4. Then alpha square will be what? It's a squared 1 minus 1 over h what? H squared, right? So this is my area. Okay, so now by slicing methods here, so the volume will just be what? The volume will just be you integrate the areas, right? So you integrate the area. So what is my y value from 0 to h here? So from 0 to h, and then this is the square root of the 3 over 4 a square 1 minus h to the square dy. Okay, so now we can move a lot of constants out. So this is the square root of the 3 over 4, the a square. Well, all right, so then this is 0h, then this is 1 minus h, the square, the dy. And now the inside here, you can just use a simple U sub and you can find the integration. So this is still my constants is a square, and this integration will be negative 1/3 h, right? So this is 1 minus 1 over h third, right? So n plus 1 now just the constants. And then what is your upper bound, the lower bound? Is will be from the 0 to h here, right? Okay, so now so this one here is the square root of the 3 over 4 a square. And okay, so minus, so like this is times, right? So times, this is the integrations here. Okay, so times, when you put the h in there, so when you put the h in y's, right? So here now, what you need to do is here, you place the h into the y and the 0 upper bound, the lower bound. So when you put the h to here, what you have here, you will have zeros, right? Because 1 minus 1 is equal to 0. Then when you put the y equal to 0 here, what do you have? You have a minus what? You're going to have a minus 3 what? You're going to minus 3, then here is what? It's h. Correct? All right, so you will have a 0 minus 3 will be the h here, and then you have another minus here. So that's what we're going to, let's see here, did we make any silly mistakes here? So you can, oh, minus here, right? So minus here. Okay, so that's why this is a minus minus h over 3. When you substitute the upper bound, the lower bound. So the final answer will be 4 square roots of the 3 a square h over what? H over 3. Then you can say this is square roots of the 3 over what? 12, right? 4 times 2, this is 12. And then you have a squared to the h 0. Okay, that's it. That's how do we find the perimeter of a triangle, the triangle perimeter here. Okay, so the things here, I think is a little difficult. Is like when you see the cross sections, right? So you cut this blue things here, right? So you need to know, what is the height, right? So you want to have, so you want to know how do you relate it to this side to the A, and relate it to the height to the H here, right? So it's just like use the similar triangle. So this is kind of like a little hard, but if you draw this picture, I think you probably can see that, right? So basically we are working on this side. So I think that this is the one, this is the kind of that a big triangle and a small triangle. I use the triangle similarity of the similar triangles and try to find the ratios here. All right, that's it. It's very interesting. The problem is a little harder than the other because you really need to kind of be able to see the cross sections there. All right. Okay, so that's it for this lab. We are doing the volume of the triangle pyramid. All right, so nice talk to you, and maybe we'll work on the next lab together. Okay, bye.